Good morning students. Last time in the metallurgy topic we had discussed about how to concentrate the different type of ores. Okay. Today we will discuss how to extract the metal from its concentrated ore. Okay. So once the ore is concentrated, then it is subjected to process like roasting and calcination. Okay. So what are we discussing? We are discussing the extraction of metal from the concentrated ore. Okay. In this, the first process which we do is calcination. Okay, calcination matlab burning of the ore. It is burning of ore in absence of air. Means without the air or with minimum amount of air. When you are burning the ore, then you will be converting the ore into the oxide form. Now here which ores are which ores have to undergo calcination? The ores like carbonates, okay, this is ZnCO3, zinc. You are heating it and you are doing this in absence of air. That means with there is no air present in it. So what it will get converted to? It will get converted to ZnO plus CO2. Okay? Similarly, you can have FeCO3, siderite, that is iron carbonate, ferrous carbonate. It will get converted to FeO plus CO2. So all the carbonates are removed from here. This is called as calcination. So all the carbonate ores or the ores which are present in the carbonate form, you carry out calcination and get converted to oxide form, because oxide form ka reduction is more simpler. So all the ores you just convert it into the oxide form. Okay. The next process which you can have is roasting. Now what is roasting? It is burning of ore in presence of oxygen. That means you pass air and then you carry out. और इस इधर किस तरह का ore होता है? All the sulfide ores. यहाँ पे which kind of ores? This is carbonate ores. Okay, ores which are present in the form of carbonates. Now ores which are present in the form of sulfides, they are undergoing roasting. Okay, similar way, जैसे ZnS with O2 gives you what? The sulfide form. Okay, it will get converted to ZnO plus SO2. Okay. Similarly, any sulfide ore, it will get converted to corresponding oxide and the sulfur dioxide is removed. So roasting is done this way. Okay. Iron sulfide or ferrous sulfate, any sulfide ores, it will get converted to the oxide by burning it with excess of air. This process is called as roasting. So after roasting and after calcination, you have got your metals in the form of oxides. Now oxides may say you have to remove the oxygen, and that process is called as reduction of the metal oxides, or it is called as smelting. Okay. So the next process after roasting and calcination is done, the third process is what we call as smelting. Okay, smelting is to remove oxygen from the oxide ore with the help of heat, with the help of heat, और इसको हम कहते हैं pyrometallurgy. ओके, जो लीचिंग प्रोसेस हमने किया था विद द हेल्प ऑफ सम सॉल्वेंट और सम सॉल्यूशन, इट वुड बी कॉल्ड एज, वो जो प्रोसेस है दैट इज कॉल्ड एज हाइड्रोमेटलर्जी. ठीक है, अब दिस इज पायरोमेटलर्जी. द ऑक्साइड ओर विद द हेल्प ऑफ हीट टू रिमूव द ऑक्सीजन फ्रॉम द ऑक्साइड ओर विद द हेल्प ऑफ हीट. फॉर एग्जाम्पल Fe2O3, you carry out smelting with O2, or you can write the reduction reaction. Fe2O3 with CO, carbon monoxide, will get converted to FeO, then FeO again with carbon monoxide, it will give you Fe plus CO2. This is called as the smelting reaction. Actually ये reaction जो है ये blast furnace में occur होता है. Do you remember how the blast furnace had the structure of the blast furnace? It was this way. Okay, the inner lining of the furnace was done with fireproof bricks, means which can withstand very high temperature. Okay, from here you were adding what? The ore of iron, which can be Fe2O3 or Fe3O4. Okay, along with that you were adding CaCO3, which was limestone. Okay, it was limestone. Also you were adding coke, but you can see Fe2O3 reduces with carbon monoxide and not coke. Okay, from the extreme end, that is bottom of the blast furnace, you were passing air at very high temperature. Okay, so at very high temperature you were passing air around, the temperatures are given in your book, so you can take the exact temperatures from the book itself. Okay, it will be various temperatures are given at very low very high temperature, more than 1000 degree Kelvins. What is happening? This particular carbon, no, so I will write here. Okay, above 1000 degree Kelvin, you were obtaining the reaction which occurs is carbon reacts with CO to give you CO2, and CO again reacts with O2 to give you 2, that is carbon monoxide. I am sorry, this is CO2. Okay, CO2 again reacts with O2 to give you carbon monoxide. I am sorry, CO2 again reacts with carbon to give you carbon monoxide. Now it is okay. Carbon which was added as coke into the blast furnace, it reacts with O2 to give you CO2. CO2 again undergoes reaction with the coke and gives you carbon monoxide, and this carbon monoxide will be traveling upward. ठीक है. Now at the temperature range of 500 to 900 Kelvin, this is the temperature range where the reduction of this iron oxide takes place. So which are the reaction it undergoes? Fe2O3 plus carbon monoxide gives you Fe3O4 plus CO2. ठीक है. Then Fe3O4 plus CO again gives you FeO plus CO2. Okay, and then FeO plus CO gives you Fe plus CO2. So these are the reduction reactions which are occurring at temperature range between 500 to 900 Kelvin. ठीक है. अब ये जो Fe2O3 हम ऐड करते हैं, Fe2O3, it has various impurities like SiO2. ये जो है, this is our ore. Our ore will have the impurity of SiO2. ठीक है. Now that SiO2 has to be removed, isn't it? So that SiO2 is removed by adding a, you can write here SiO2, it is the impurity present with Fe2O3. It has to be removed by a flux. Okay. SiO2 जो है, this is an acidic impurity. Okay. So you will add a flux which is basic. अब ये flux कहाँ से आएगा? The flux is obtained from the CaCO3 which you are adding. So here what is happening? At a temperature around 1000 degree Kelvin, what is happening? CaCO3 gets decomposed into CaO plus CO2. So this CaO will react with SiO2 and form CaSiO3, which is called as slag. It is called as the slag. Okay, and this slag, you have obtained metal here, so metal Fe will float here, ठीक है, और उसके ऊपर you will have this slag floating above the metal. Okay, this is your Fe metal which is in the molten state. Okay, and this is the slag. The slag will remove the impurity of SiO3, that is one of its use. Also it will prevent the Fe metal which has already got reduced. It reduces the prevents the Fe metal from coming in contact with the air and getting oxidized to FeO further. So it has two functions. Followed? So this is how the reduction process or the smelting of the iron oxide takes place. Have you followed? Okay. So this is the blast furnace and these are the reactions which are occurring in the blast furnace. This occurs around 1000 degree Kelvin. Okay. Then the CaO which is formed, it will react with SiO2 and give you CaSiO3 slag which will float over the iron. Clear? Okay. So this is the various reactions which are occurring in smelting. Okay. Now we will learn the smelting process of copper, how to obtain copper from its oxide. So again see, CuFeS2, this is the primary ore of copper which we are taking. Okay. So when you heat it, you will get Cu2S plus Fe2S plus okay. Okay. So here you obtain Cu2S, Fe2S. Okay. This copper pyrite actually you are taking in the reverberatory furnace and you are carrying out this equation. Now this Cu2S should also react with O2, also Fe2S should react with O2. Okay? This you are talking about the oxidation process, that is roasting. Roasting mein you will find that this Cu2S will have less affinity for oxygen than Fe2S. So what will be getting converted first into oxide form? The Fe2S will be getting converted to Fe2O plus SO2. This is the reaction which is, this is not a balanced equation, I am just trying to make you understand how this reaction occurs. Fe2S has more affinity towards oxygen, तो Fe2 सारा है Fe2S जो है वो convert हो जाता है FeO में, ठीक है. This Fe2O will then react with carbon and give you Fe plus CO2. This is how the reaction will occur. Okay. So, Fe2S will react with O and give you Fe2O. Okay? Now you have obtained FeO. Now it is ready for the conversion into that is, it is ready for the reduction process. Okay? But we want the copper metal. FeO is getting FeO is formed from Fe2S. Now the Cu2S will react with O2 and give you Cu2O. Okay, but ये जो Cu2O बनता है, that will again react with Fe2S जो कि small amount में अगर present होता है, so then it will give you what? Fe2O plus Cu2S. इस तरह बन जाएगा वापस से. Okay, then when all the Fe2O is formed from the Fe2S, then the copper sulphide will get converted to copper oxide. Okay, copper sulphide reacts with oxygen to give you copper oxide. ये लास्ट में होता है, beginning में this won't take place because oxygen has more affinity towards iron sulphide. Iron sulphide will react with oxygen to give you iron oxide, and iron oxide, when all the iron oxides are obtained from the Fe2S, then only you will find that copper sulphide getting converted to copper oxide. So, you see here, even if the copper oxide is formed in some less amount when copper sulphide reacts with oxygen, that copper oxide will again react with the unreacted iron sulphide and get converted to copper sulphide again. When all the iron sulphide has got converted to Fe2O, then Cu2S will get converted to Cu2O. Okay, then Cu2O plus Cu2S gets converted to Cu plus SO2. Cu2O जो बनता है वो जो CuS ऑलरेडी प्रेजेंट है, सारे Cu2S इज नॉट कन्वर्टेड टू CO, नो. तो इन दोनों के बीच में सेल्फ रिडक्शन होने के कारण Cu प्लस SO2 बनता है, और ये जो Cu प्लस SO2 बना, दिस इज योर ब्लिस्टर कॉपर. व्हाट इज इट? इट इज ब्लिस्टर कॉपर. इट हैज SO2 ट्रैप्ड इन इट. ओके, एंड दैट हैज टू बी रिमूव्ड. अब ये जो FeO बना, this FeO is remaining as an impurity, no? So that has to be removed, and that is removed with the addition of SiO2, giving you FeSiO3, which is called as slag. It is an impurity, it is being removed. Okay, this is iron silicate. What is it? It is called as iron silicate. Followed everyone? Okay. So, this is how you can find the extraction of copper. Here you have extracted copper, and previously in the blast furnace you had seen you have obtained the iron. Okay. So, this is the extraction of copper and iron we have discussed. Okay. This extraction of copper is taking place in the reverberatory furnace. So, if it comes as a short note, you have to write all the equations given in your textbook. Okay. So, go through the textbook thoroughly and try to understand it. Okay. Thank you.